In most enterprises, certificates are everywhere, and many of them are invisible until one silently expires and takes down a critical service. In this topic, we'll bring that chaos under control with automated discovery, renewal, and hands-off deployment to your endpoints. Treat certificate automation as a continuous engine, not a one-time project. You begin by discovering what actually exists: every certificate, every issuer, and every mystery endpoint. Once you have that view, you centralize the facts in a single inventory instead of relying on spreadsheets and tribal knowledge. From there, you assess risk. Which certificates are weak, close to expiry, or business critical? That drives prioritization. Then you handle renewal and deployment. Renewal issues the right certificates at the right time. Deployment reliably pushes them to web servers, devices, and applications. Monitoring closes the loop, tracking health, failures, and drift, so your PKI footprint stays continuously under control. Network scanning is your first discovery workhorse for PKI. You sweep defined IP ranges and DNS zones, probing ports like 443 or 25 to find anything speaking TLS. For each responding service, you don't need credentials. You just complete enough of the handshake to pull the server certificate. From that certificate, you harvest metadata, subject and sans, issuer, validity window, key length, and algorithm. This quickly surfaces unknown endpoints, weak keys, and soon-to-expire certs. The key advantage is that it's non-intrusive and scalable. You gain broad visibility of external and internal services. Then feed those findings into your CLM or inventory to close gaps before they cause outages. When you design certificate discovery, think in layers, not a single magic tool. Network scanning gives you the widest coverage. It's ideal for mapping internet-facing TLS endpoints, but it only sees certificates on actively listening ports, so anything internal or dormant remains hidden. Agent-based scanning works from the inside out. Running on the host, it can inspect OS and Java key stores, local files, and services that never expose a port externally. You trade deployment effort for deep visibility. Platform API integrations complete the cloud picture. By talking directly to AWS ACM, Azure Key Vault, or Kubernetes, you see certificates that may never traverse the network at all. Your first discovery run usually uncovers more issues than you can fix at once, so you treat the results like a funnel and filter them by risk. Start with system criticality and environment. Production, internet-facing systems go to the top. Non-prod and internal only often wait. Then examine issuer trust and crypto strength. Public versus internal versus self-signed, and flag weak algorithms like RSAs and 124 or anything on SHA-11. Finally, add time pressure. Certificates expiring in the next 30 days get urgent priority. The outcome isn't just a list of bad certificates. It's a prioritized remediation backlog, mapped to specific service owners that you can feed directly into your CLM onboarding plan. Renewal design needs two modes, calm and crisis. In calm mode, you're doing routine maintenance. You renew well before expiry, typically 30 to 60 days out, or at a fixed percentage of lifetime. The goal is zero drama, automated Acme-style endpoints, background issuance, and pre-approved workflows that rarely need human involvement. Crisis mode is different. A key compromise, key leak, or broken algorithm forces rapid action. You trigger bulk reissuance, bypass normal approvals, and push certificates aggressively, often with shorter validity. Mature CLM design builds in both paths and lets you switch between them instantly. Once the CLM platform has a new certificate and key, orchestration diverges based on the target. For web servers like IIS, Apache, or Nensk, automation typically copies the cert and key into the correct path or store, fixes permissions so only the service account can read the key, and then triggers a graceful reload. The objective is to swap certificates without dropping live connections. For ADCs and load balancers such as F5, Citrix, or Cloud ALBs, you generally drive changes through APIs. You update profiles or virtual servers, stage the new cert in a blue-green configuration, drain existing connections, then flip traffic over with effectively zero downtime. Think of your orchestration payload as concentric defense rings around one asset, the private key. If that key is ever exfiltrated, every other control is theater. Closest to the key, use cloud key vaults as the system of record, not random config files or app settings. Keys should live in Azure Key Vault, AWS KMS, GCP Secret Manager, or an equivalent platform. Around that, enforce strict access control, role-based access, least privilege, short-lived tokens, and mutually authenticated TLS between orchestrator, vault, and endpoints. The outer ring is hardware. Wherever possible, generate and store CA and other high-value keys in FIP-certified HSMs, so the material is non-exportable. When you design automation, validate each ring explicitly. Don't assume the platform handled it for you. In a mature PKI deployment pipeline, every change to a certificate or TLS endpoint is treated like code. Validate, test, gate, and then either commit or roll back. You begin with automated pre-deployment checks. Verify that the certificate is syntactically correct, chains to a trusted issuer, and matches hostname and key requirements. Next, deploy into a staging or canary endpoint and run real health checks. Full TLS handshakes, application probes, and dependency checks. A decision gate consumes those results. If everything is healthy, you promote to production and re-verify. If anything fails, automation should immediately roll back to the last known good certificate, raise an ITSM ticket, and block further attempts until a human investigates. Think of certificate operations as a maturity journey. Most organizations start in a manual world: spreadsheets, ad hoc CAs, surprise expirations, and constant firefighting. The initial goal isn't perfection, it's escaping that chaos. The transition stage focuses on automation. You centralize inventory, script renewals, integrate with cloud vaults, and start using risk to decide what gets attention first. Outages drop, and PKI becomes predictable. The target state is intelligent, zero-touch operations. Discovery is continuous, onboarding is risk-based, orchestration avoids downtime, and rollbacks are automatic. As you go through this course, keep mapping each technique and pattern back to these 3 stages, and decide where your environment is today and where you want it to be in 2 years.